I sometimes see data scientists go to the most complex algorithm out there to solve a problem just because it's cool and it's fun to use it. But sometimes just a logistic regression would do. You just have to have the right data.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Here with me today on How AI Happens is senior data scientist over at Bell, Dalia Shanshal. Dalia, welcome to the show. How are you today?
I'm good. Thank you. Thank you for having me.
You are powering through COVID at this
Yes.
moment. You had rescheduled last week because you were feeling like you got hit by a truck. Doesn't sound like you're feeling much better now, but you are an absolute champion in powering through. So shout out and respect to you for getting on with it.
Thank you so much. I was very excited about this. And then last week when I got sick, it wasn't ideal. And I thought, you know what, this week I'm just going to go for it. And so let's get it going.
Yeah. It's I'm really glad you decided to do that, and it's a little benefit of doing a remote podcast is that it's possible for us to do this in a safe and carefree manner.
Yeah, exactly.
So something I didn't know when we first met, Dalia, is that you were fresh off the heels of having been master of ceremonies at GeekFest, which is like Bell's internal conference / hackathon. So I'd just love to know more about it. How did that go?
Sure. So let me first tell you a little bit more about the GeekFest conference. This was the 6th annual GeekFest conference. It's an internal conference that Bell's Network and Technology Services host each year. It was a virtual event. The focus really is to get all software developers together, data scientists, to talk about the latest innovation and within, the software development work, cloud services, data, and machine learning. So last year I presented what they say is a lightning talk. So it's a 5-minute talk about a project that I was working on. But this year I had the opportunity to MC at the Bell CTV studios, actually in Scarborough, Toronto. And it was really fun and an exciting new experience for me.
So what kind of panels were you moderating?
I was actually doing the hosting. So the opening, the closing, introducing the talks. There was one panel that I moderated, which is the DevX program. I don't have some notes right now. It's been quite a long time. But the DevX program is how to integrate and create this golden path for software developers.
Got it. Okay. What kind of stood out to you? Were there sort of notable discussions or like what kind of conversation about AI was taking place here?
I'd say this year the most focus was on, the cloud and the moving the data to the cloud and leveraging cloud services. And a lot of talks were on how do we leverage cloud to have greater operational efficiencies and enable better application performance by modernizing our IT infrastructure. So that was one of the really main emerging topics this year that I noticed. Other topics, of course, are on AI ML innovative application that focuses on reliability of our network. So how do we leverage machine learning and AI to make sure that we are proactively resolving all network disturbances out there? So there are many initiatives on that end. Another topic that was also interesting is the impact of the agile framework. So the movement to this agile framework, which has been in place for quite a long time right now, but there was an interesting talk about how important it is on team success and how important it is to create a culture of trust, of innovation, and engaging collaboration. And that all feeds into the success of software and AI ML projects. So also the importance of people, not only the technology.
It sounds like a industry conference, like a trade show, but Bell is sufficiently large that you can kind of execute that kind of thing just internally, which I'm tickled by.
Oh, yes, 100%. There was around, if I'm not mistaken, more than 400 attendees per day. And it is a big event. And it's really exciting because we were actually shooting it live. So first time on live camera. So that was definitely out of my job description. But yeah, we have the infrastructure to host such an event. And there's a lot of interest in that as well.
So I'm sure our listeners will be familiar with Bell, with the trademark, with the logo. This company has been around for a long time, since the late 1800s, I believe. Founded by Alexander Graham Bell, the inventor of the telephone, I'm sure people will recall. And you are on the Canadian subsidiary of Bell, working more on the research and development side. So I would love to know a little bit about your role and what it is you're working on over there.
Bell constantly improve the hardware and the software anywhere in the network. Why do we do that? Of course, it's to provide the best technology, best services out there to our customers. And so what the team I work with does is really at the heart, I'd say, of the new product and services. And so when we launch a new product or a new service, we want to make sure that customers are having a similar experience or a better experience than the previous one. If at any point we see this, then the team I work with is responsible for raising the flag and saying, hey, let's pause. We might have some bugs here. Let's review. So we would review with different teams, with product, with our engineers, with our vendors, with fields and technicians. And so what I do is really try to leverage AI ML to speed up and fast track those investigative processes.
Okay, got it. That's helpful. I want to dig into that, definitely. But first, I'm just curious to learn more about your background and how you came to be at Bell. So you've been around the block a couple times in the field of data science. I would love to know how you've kind of seen the space evolve a little bit. Data science has historically, within the last 10 years, been a very sexy job, right? And I'm just curious how you've kind of seen the space evolve in that time.
Mm-hmm. It's funny. Well, let me first tell you about my journey, and then maybe we'll talk about data scientist being the sexiest job and if it's still the sexiest job. So let me tell you about my journey. I actually did not study data science in undergrad. I did economics at McGill and I focused on stats because I've always loved math. And I had no idea what data science was. It was back in 2014, 15. And then I was, just browsing online about potential actuarial courses, certificates, and I bump into an article saying data scientist, the sexiest job of 2012. And I'm like, what is data science? And so I decided to pursue a master's in data science. I really liked it. I worked in academia, in teaching and research at TMU, Toronto Metropolitan University. And so that's really how I got into data science, super randomly through an article online that just piqued my curiosity. And I realized that I love that. If we go back to how it evolved and based on my experience, well, first of all, why was it called the sexiest job? Well, because at the time it was, and it's still rare and brings huge value to the company. Data scientists today are key in business decisions. We always need business decisions based on facts and data. And so to have the ability to mine that data is super important. What I saw the most change overall in the data science field is when I first started to look into data science, there were very, very few formal university programs and certifications. And so today, there are plenty online in universities. So that's good because, well, it kind of helps determine what the skill sets required are for a successful data scientist and have a consensus on that. Now, the challenge there is it evolves super, super fast. So I remember when I first started my certificate, Hadoop was the big hype. It was Hadoop, parallel computing, and all of that. And I remember my professor was just telling me about this big query paper that Google just published, but there wasn't a lot of talk about it. Today, we're moving to the cloud. We're moving away from Hadoop and from local storage and more to the cloud. And that happened in just like 5 years. So it's exponentially evolving, and we all know that. So that's a bit of a challenge there in programs and certifications, especially because I do have some teaching and research experience. So I know how things evolve very quickly. Another change that I noticed in the evolution is a better separation of data roles. So a data scientist in 2015 probably should have been a unicorn. I don't know if you've heard that, the data scientist, the unicorn. There was a lot of expectations from what a data scientist has to bring. And so there was expectations for data scientists to know everything from data engineering to data analytics, machine learning engineering, all of that, and even software development. There was a lot of mix between what companies wanted from a data scientist. And I see today there's a better segregation of the roles. So it'll be clear that a data engineer won't do the job of a data scientist. A data scientist brings something else to the table, more focused on how to analyze the data rather than, get the data in and optimize the queries. It's more based on, which algorithms to use that are more beneficial to this type of data, to this type of problem, how to solve the problem. That's, I think, what the best data scientist, a good data scientist is to well, definitely a good data scientist needs to have the skill sets, academic and soft skills, but the most important skill set is to be able to have creative approaches to problem solving. That's why we're called scientists. So, for example, I don't know if you've heard about that one. It was actually in the article of the Business Review. Data scientist is the sexiest job of 2012. They give an example of how a data scientist was able to optimize fraud detection or come up with a fraud detection system by using a DNA sequencing algorithm. So that is, in my opinion, the beauty of a data scientist's work is that creativity in solving problems with data. That's what I think changed. So if I want to answer your question, is I'd say, academically things are changing, the technology is evolving vastly, very quickly, and then the role of a data scientist is becoming more clear what they should bring to the table and their skills. Also, on another note, there's this shift in the practical uses of data science projects. In fact, a lot of data science projects fail in the industry. And part of the reason is because we are so much focused on the algorithm, which algorithm to use, how to optimize the algorithm, but we often forget about the data that we're feeding into it. And so what's interesting is I sometimes see data scientists go to the most complex algorithm out there to solve a problem just because it's cool and it's fun to use it. But sometimes just a logistic regression would do. You just have to have the right data. And if you have the right data, you use a simple algorithm, less computational power, and you're solving your problem faster. So I think that approach to data-centric AI is very important today. I'm a big proponent of it. The term data-centric AI has been named by Andrew Ng, and I know that he is working on creating a systematic way of approaching data, because we know how to approach algorithms, right? We know, okay, we feed the data, we train the algorithm, we test it, the accuracy, the performance, go, no go, we do another round, we update parameters, all of that. We have a system to that. But we don't have a system of, well, what data do I feed in? What are the requirements of the data that they need to feed into that algorithm? And if I have that, then that would make data scientists' work much faster if there's a system to it, more efficient to the algorithm because it is fed into the algorithm. And it's whatever you feed into the algorithm is also very, very important, as important as the algorithm's capacity to learn from the data. I hope that makes sense. I kind of rambled a little bit about everything, but I hope that makes sense.
It totally does. Yeah, yeah. And when you say it would be easier if there were a system around data, are you referring to an organization's approach to the way they source, clean, like a strong data
Yes.
foundation, basically?
Yeah, exactly. More focus on a practical or academically, theoretically, practically, how do I approach which data do I need to use? Why do I need to use this data? How do I clean it? I know that there are methods here, but there is no one system. So the feature engineering, there's a lot of domain expertise that needs to come into the process of a data scientist's work. The data scientist knows the algorithm, but we need some domain expertise. We need a system that helps us determine, okay, I want to use neural networks, okay, for this kind of problem. That's the data I have. What's the process? How do I evaluate how well the data is for that algorithm? So a little bit like that, yeah.
Yeah, that makes sense. Now, when you gave an example there of like, oh, why would you bother with an algorithm when a logical regression might be a better approach? And that is not going to make you popular with venture capitalists,
I know.
right? But it
I
might
know.
actually solve your problem. And it's similar to what you had said a minute ago about how Hadoop was all the rage in 2012. And it's like, the point is that there are these very shiny tools du jour, right? That it's
Yeah.
like popular to use. But someone like you, and I think lots of people listening to the show, are the folks who are just like, listen, forget the hype. I know how to roll my sleeves up and get this job done. And so with that perspective in mind, it's less important to know Hadoop or any given single language, right, or approach. Would you agree? And then it's
100%.
more about the problem solving part.
100%. For me, that's what makes all the difference in the practical use of data science. That's what makes all the difference is how do you approach the problem? How do you solve it? Because everybody can learn how to code. Everyone can learn all the algorithms. That's great. So I can be a doer where somebody would tell me, hey, do this, 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 and I'll code it. But the data scientist needs to have a creative mind to apply things. And a lot of the time, I see the really impressive applications of algorithms that are typically used in a domain that are being used in a completely other domain. And they're working super fine and they're bringing a lot of value to the company and organizations. And that's what's important. Yes. And I'm always a proponent of start simple. Well, it depends, but I always like when it's business problems, I always like to go simple first and test it because there's a thin line between, because efficiency is important. If I was in research, sure, I can, take my time to develop new things, complex stuff. Sure, it's fun. But when I'm in the industry, I need results quick. That's why we're hired. Start simple, get some proof of concepts working. And if it doesn't work, then quickly shift to another approach.
It's so interesting. I'm hearing this more and more that the technical ability, the technical know-how is more table stakes in your field, right? It's like, okay, we expect R, we expect you're familiar with Hadoop, we expect you can, take one of these models or algorithms off the shelf and figure out how to make it sing for you. But it's more about the other stuff. It's more about someone's creativity, problem solving skills, ability to work in a team. It's like, okay, your long laundry list of skills on your resume doesn't impress me as much as your ability to get a job done. So I'm curious, like, it's interesting to me that it's like when you say anyone can learn to code, that it's like, okay, this is a commodity, this is table stakes. What else you got? I'm curious, like when you meet with people, you must have been surrounded with fantastically well-educated, right, academics and people who have these technical abilities your whole career. What is it that actually impresses you? What can someone say where you're like, okay, despite all that technical know-how, I actually think you might be able to get something done outside of knowing a given, language of the language du jour?
Mm-hmm. That's a really good question. I mean, again, I'll have to go back to problem solving and creativity. What impresses me the most is making those links. Actually, I have a brilliant intern right now who I would love to share what he's doing because that's someone who impressed me with the way he tried to find solution to the problem. So how can I say this? What impresses me the most, innovative ideas. So there's a difference between saying, okay, I have this problem. Okay, I know that there's this algorithm from this library. I'm going to take it, apply it, accuracy, done, performance, done, deploy it. Okay, but two things are really important. Is the business really using it? Or is it just running there on a dashboard? Nobody's using it, no value. And number two is that's maybe something that's also really important is, are you able to communicate how your process is going to help the business so that end users are actually going to use it and not just have it there? So communication and creativity and problem solving, these three, when someone has it, really, I think, impresses me. And I've been surrounded by really, really brilliant data scientists and, as you mentioned, academics, researchers, and I learned a lot also from them. A lot. I've also learned a lot from the domain experts. I think it is super, super important to keep the conversation going with the domain experts and the end users who are going to make decisions based off the data that you're giving them, based off the output of the algorithm that you're giving them. It's not an easy task to communicate very technical work to, business in a simple and concise way. And so that's really important. It's important for them to understand how things work and how that benefits them, and to work together, whether it's from, the data part, understanding the data, what features we're using, why did we do the change of the features that we used. I think they have to be very closely on board with that, as well as the output. They don't necessarily have to understand the algorithm and how it works, but the output of it and how they can leverage it and use it.
I definitely want to get into that, because quickly though, I love a moment ago how you just reiterated the scientist half of the data scientist part, because I'm guilty of just glazing over that, forgetting that that's half of it. Like in the same way, oh, what's a software engineer? Like, what does it mean to engineer, right? It certainly doesn't mean to sit in meetings and talk about like a slideshow. But with the data scientist part, like this is a process of testing, of experimenting, and crucially of research. And you are able to keep that researching hat on both inside and outside Bell, which is part of why I was excited to speak with you. You recently had some of your work featured by AI Montreal, and I was hoping we could talk about that too.
Sure, yes. So it was a paper that was accepted and published in the Canadian Artificial Intelligence Conference. It happened in Montreal. Each year it happens in different areas of Canada, but this year it was in Montreal and McGill in my...
Your alma mater.
Yeah, exactly. It was really, really a humbling moment to come back and see yourself going back as an industry professional as opposed to a student. So maybe I want to give you a little bit of a background. So my role exactly is not specifically research, but because I just love research. And I think it's very important for data scientists to keep up to date with the science. And I always, when I'm tackled with a problem, I always start with researching what's out there. And so that's why I decided to, and I came up with that framework that I'm going to explain to you right now, that is now published, and people can go read the paper. And, if they have any comments or feedbacks, I'd be more than happy to hear about that.
Careful. Careful opening those floodgates.
Oh, yeah, right?
No,
Okay.
I hope so. We'll definitely link to the research, and
Yeah.
you should. I'm being cheeky, but
Okay.
yeah, I love that you're just inviting, opening the floodgates. Like, yeah, tell me what you think. But yeah, for sure. I mean, that's what science is, peer review.
Exactly.
So.
And the more feedback and comments I can get, the better we can all work together. I think that's great. I love that. I love brainstorming in teams and, exchanging ideas. And so it's just part of my passion. Maybe let me talk to you a little bit about the work itself, with the paper itself. So the paper is called Towards an Automated Root Cause Analysis Framework in the Canadian Telecom Industry. It's a framework that I came up with. And again, it comes back to a very simple idea, but just nobody did it out there. So remember how I was telling you, let's say, I'm going to give an example. Let's say, okay, tomorrow I am launching a new software version on a modem. How do I see how well it's performing? There are many ways, but one of the ways is the call rate. And so what we do is like an A/B testing, where we look at the call rate of that new product that we're launching and the current product out there. And if at any point we see a difference, then, like I told you, what my team does is, we raise the flag and we do the investigations. So it's an iterative process, and it's not humanly possible to do all of the permutations. So what I was thinking is, well, can I automate that? So what I was thinking about is an algorithm mainly really used in marketing. It's association rules algorithm. So you can check a priori algorithm, FP growth algorithms. There are different variations of it. But the idea is, I have a grocery shop, and then I have a list of transactions of what customers bought. So I have, let's say, thousands of transactions. And for each transaction, I have the items. So I have orange juice, milk, coffee. Okay, and then second transaction, I have orange juice, milk, pencil, etc., etc., etc. And when I feed that list of transaction items to my algorithm, what it's going to give me, okay, if your customers bought milk and orange, then the probability of them buying coffee is 5%. Okay, so basically it's taking all the subsets and giving me the probability of a third item. Now, if I translate this into my use case, some transactions, some of my customers will have calls, some won't have calls. So now I put this information into the algorithm. Now I have in one shot all my call rates. Now the data is giving you leads. So that's kind of how I translated this into the use case we were trying to solve.
So the data is like you would expect a call rate to be X%, and anytime it deviates from that, now you have something to investigate, right? Is that the lead?
That's the overall call rate. Yes. If it deviates, then I need to investigate. But I need to investigate what's the contributor, what characteristics, what component or what characteristics do I need to look into so I can then say, hey, engineers, take a look at these cases.
Okay. Yeah, I mean, this has implications for like site reliability, for like any time there's uptime, basically, right? It's like, okay, what is the interruption here? You can detect it, and then your approach to this allows you to be even more granular with your detection.
Exactly. More granular with the detection. Hey, KPI is telling us something, an alarm. Okay, can we get more like surgical? Well, yes, we can. We can either do it manually and it will take us weeks, or we can do it through an automated algorithm and it's going to give us the output directly and help guide us. Now, it's not going to give us the golden nugget, but definitely much quicker for investigations.
Got it. Yeah, it's brilliant. I can see why it's been useful at Bell, but again, I feel like it has implications for any sort of reliability
Any new
application,
product,
right?
any new product, as long as you have a KPI set, any new product that you want to launch, and it's like a complementary to an A/B testing, because A/B testing would tell you, yes, there's a significant impact, or no, there is no significant difference. But if there is a significant difference and it's not a good difference, like the KPI is not doing well, then okay, how do we go about to analyze it? Then that could be a complementary step to any product launches.
Right. Just much more specific. Like, in marketing, an A/B test is like, oh, the email with the orange banner clicked better than the email with the purple banner.
Yes.
Right. But then with this approach, you would be like, oh, well, why orange
exactly,
though? Like let's
exactly.
zoom in on orange. Yeah.
Yeah. What are the characteristics of people who clicked on orange and people who clicked on purple? And where's my highest difference? Exactly. Yes.
Yeah. This is fascinating. So when you spoke to AI Montreal, did they have follow-up questions? Were they just like, we're going to publish this and discuss it? Or what was sort of the fallout of having it published?
Well, the goal of having it published is really to have engagement from the community and, showcase this new innovative way of approaching things, and you contribute to the field. And also it was a really good opportunity to network with people and get their insights and see what everybody is doing as well in different domains.
That's such a scientist answer. What was the point? The point was for knowledge. Is the point is to drag ourselves 1 millimeter closer to automated nirvana, right?
Yes, exactly. That's beautiful. Exactly. Yes. It's to contribute and see what's out there and just intellectual stimulation. It's fun.
Yeah, absolutely. Well, Dalia, we are right here at optimal podcast length here, having been intellectually stimulated. And I would just like at this point say thank you so much for being here. I love learning about your work, your general approach to data science, and reflecting on the maturity of the organization. In the spirit of knowledge and peer review and all those scientific pursuits, Dalia, before I let you go, is there anything you'd like to share with the community out there?
Yes, I do. I would like to share my passion about tech for good and using technology for good. One of the things that is really important to me is making sure that whatever we are doing has an impact. I'd like to highlight a special project that I'm working on. It's called the OMDOM project. What it is, it's a public art installation. And the idea is that art and technology merge together to inspire unity. I'm going to give you a brief summary of what the project is. So we're hoping to build this dome, and there's going to be sensors. It's going to be done on a Raspberry Pi. And when you enter the dome, your heartbeat is going to be set. The sensor will get your heartbeat and the dome will start to light up. And then the more people come in, the more heartbeats there are, the more light there is, and it will light up into the tree of life. And so that's an artistic venture that I'm taking on the side with an ex-colleague of mine at McGill University who's a philosopher. I just wanted to maybe share a link to that if anybody's interested. We're always looking for volunteers, whether they're from the arts industry or technology. I think blending the two together is very inspiring. It's a beautiful cause. And so these were maybe the last words that I would like to share about making sure that whenever we're working in tech, we always have a mindset about what is the goodness of the work that we're doing, whether it's at work or whether it's outside work. And in that case, I wanted to highlight Omdom, which is an artistic endeavor that aligns with technology.
It sounds beautiful, Dalia. We will make sure to include some links in the show notes so people can check it out and volunteer, help out, contribute in whatever way they may like. Thank you so much, Dalia, for being here. I have loved chatting with you today. This has been a great episode.
Thank you so much. That's been great. Thank you very much, Rob.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI. Specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.